We are the UPRM Solar Boat, a student-driven solar boating team. The Solar Boat Team is composed of electrical, computer, and mechanical engineering. The team has been working on the project since 2014, and we have been competing since 2016 in Ohio. Our main goal is to participate and win the Solar Splash competition. This is an event that happens every year, and it's an intercollegiate solar boating competition. It's a 5-day event where universities can accumulate points in 7 different categories. The last competition was in June of 2021, where we achieved first place for the first time after many years of hard work and dedication. Out of 1,000 points that the competition is worth, we were able to accumulate a total of 954 points, which places us 122 points above the second place. Here we have an overview of how the performance of our boat has improved since its beginnings. On the left, we have our top speed improvements. Starting from only 4.5 meters per second in 2016 to our current top speed, which is 14 meters per second, with a 3 times performance increase. On the right, we have our endurance speed, which is the high efficiency race on the competition. We started at 2.1 meters per second in 2016, and now our boat has improved to 3.2 meters per second, almost a 53% improvement since the team started. Due to restrictions established by competition rules, the boat must use lead-acid batteries of no more than 100 pounds per bank. So every improvement over the years have been achieved while using the same batteries with 2.2 kilowatt-hour of energy. After testing, the chosen hull was manufactured to full scale using CNC machinery in order to achieve the desired geometric form as close as possible. The boat's 15-foot-long core is made from a dense foam and then laminated with carbon fiber and Kevlar honeycomb panels, reducing the weight from 110 pounds on the last boat to a mere 50 pounds without sacrificing structural integrity. For the steering system, the team transitioned from a steel Teleflex system to a much lighter and stronger cable and pulley configuration. Last semester, the team kept up with schedule by having weekly online meetings and physical testing when needed. These pictures show the new hull with 450 pounds of load, just as if it were assembled with all the other components. When comparing the old hull versus the new one, preliminary testing showed the new design to have around 19% less drag than the previous hull at the same speed and weight. Several other improvements to the overall system were achieved during this period, such as more precise instrumentation for better data acquisition, and an important battery research that is made every year and so forth. During last summer's competition, we were able to achieve first place in 6 of the 7 categories with the exception of the endurance event. This event is worth 400 points of the 1,000 point total of the competition. It consists on 2 heats of 2 hours each, where the driver goes around a course with a length of 2 kilometers. Our goal is to improve the performance on this event while maintaining the same results on the other events. Our biggest opportunity for improvement is the weight reduction of the drivetrain. The team is designing a new drivetrain that not only will be lighter than the previous one, but will be capable of accommodating a larger propeller needed for the endurance event while improving the efficiency of the drivetrain. Last year, the team designed 2 propellers, one for high speeds and another one for slow speeds, using MATLAB and Uprm'S as primary tools. These designs were made in order to achieve the desired points of operation. This year, since we want to improve the speed in the endurance event, a new propeller for slow speeds will be designed and manufactured. The new propeller will have a larger diameter and a higher efficiency than the previous one, and it will be matched to our motor. Of course, a solar boat needs its solar panels. The competition allows for up to a 480 watt configuration. Last year, we selected a solar array made by Solvian with 462 watts. Now, after researching different solar panel models, we opted for a solar array made by First Made Marine. This array will produce more power, having a 475 watt capacity. It would also reduce the total weight and size of the array, making it easier to accommodate the driver and the components inside the hull. With all the improvements being made by the team, our goal is to increase the speed at which the solar boat can move in the endurance event from 3.2 meters per second to 3.8 meters per second. All this while maintaining the same top speed of 14 meters per second achieved in the last competition. On behalf of the team members and professors of the UPRM Solar Boat, we thank you for attending our video presentation. We hope to have given an informative and useful video about our project.